confirm that you have done completing the square. You definitely did it back in Algebra 1, and it sounds like you did it in geometry as well. So again, whether or not you remember is one thing, but you've done it at least twice in your math career before. Let me fix this here. All right, so we're on page 167, completing the square. So it says, what if you have an equation that doesn't factor? So you're trying to solve an equation and it doesn't factor. So we use this method called completing the square. So the first thing I want you to highlight for yourself is the form it has to be in. It has to be in ax squared plus bx plus c equals 0. Okay, a is always with the x squared term, b is with the x, c means the constant, it has no x's. So it's always a, b, c. Okay, and our goal is, well, there's two goals. You can complete the square to put it in what we call vertex form. That looks like this, where you can see the shift. Or you can use completing the square to solve. So the benefit to putting something in vertex form, again, is you can see the shift. So this is a great review on shifting. Where does this k shift us? Up, down, left, or right, if it's outside? Actually goes up k. Okay, inside is your vertical shift. And then anything inside is your horizontal, but horizontal does the opposite. So if it said minus h, it would actually be going to the right h. Okay, so horizontal is inside, vertical is outside, and again, the horizontal does the opposite. That's just a little review that'll get tossed back in today. So step one is you're going to isolate the variable terms. Okay, so anything with a variable you isolate. And then, again, the most important step here is going to be this leading coefficient. You have to make sure the leading coefficient is a positive 1. If it's not, you just divide each term by a. Okay, and we'll go through many examples. All right, so you want to isolate the variable terms, make sure the leading coefficient is a 1. Then here's the trick to taking, or do we complete the square? You take half of the b value, then you square it, and you add it to both sides of the equation. Then you'll factor the side of the equation with the variables. The nice part is that will always be perfect squares. Okay. And then you'll either put it in vertex form, which is up here, or you'll solve it based off what the question's asking you to do. All right, so let's take a look at this first example. It says, consider this quadratic, x squared minus 8x plus 18. Use completing the square to write in vertex form. So they are specifically asking for it to be in vertex form. Okay, so we're going to go through these steps. We want to isolate the variable terms. So we want to keep these variables on one side and move the 18 to the other. So I'm going to say x squared minus 8x. It's like setting it equal to 0. Okay, so pretend you're setting it equal to 0, and all I want to do is move the 18 to the other side. So I'm going to subtract 18. So step 1, isolate the variable terms. Okay, make sure the leading coefficient is 1. Is our a value 1 with the x squared? Yes, we're in good shape. All right, so now we move on to step 2. You're going to take half the b value. So let me reiterate. A is with the x squared, b is with the x, c is by itself. So you're going to cut the b value in half. Which value is our b number? Negative 8. So off to the side, jot it down. We're going to take negative 8. To cut something in half just means divide it by 2. So negative 8 divided by 2 is negative 4. Okay, so we take half the b term. Now we have to square it. So now wrap it up and square it. What type of number should we always get? Positive if I square it. So negative 4 squared is equal to 16. Okay, now it says add that to both sides. So it's going to be x squared minus 8x plus 16 equals negative 18 plus 16. So I'm simply adding it to both sides. Okay. Step 3 says factor the variable side. So obviously this has the variables. It should factor, and it should be the same factors. So what multiplies to 16 but adds to 8? Perfect. Minus 4 and minus 4, meaning they should be the exact same every time. Negative 18 plus 16 is negative 2. Okay. So because I got 2 of the same thing, I will always be able to write that as a squared. So that's really just x minus 4 squared equals -2. Now, because it wants it in vertex form, so I'm just going to, shows us vertex form again, I'm just going to bring the 2 back. So I'm going to say this is x minus 4 squared plus 2 equals 0. Okay. And I want you to box that in. This is vertex form. Make a little note for yourself. Okay, vertex form means you can see the horizontal and the vertical shift. Okay, so part B says describe how this would be transformed. So again, it's just asking for the shifts. Where is this taking us? Which way 4? Right 4. And then this 2 is taking us up 2. So the whole point of putting it into vertex form is that you can see the shift that it's talking about. Okay. Now it says sketch the graph using the vertex form. Okay, so all we're doing, and again, this is again great review, tying in some old stuff. Now we wrote the equation, and we're going to shift the graph based on that. So we're just going to take all these points, and we're going to shift them right 4 and up 2. So just go to each point and do the same thing. So I'm going to start with the one on the right. I'm just going to go right 4, 1, 2, 3, 4, and then up 2, 1, 2. And that becomes its new point. I'm just going to do it to all of them. Right 4, up 2. Go to the next one. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. And then just make a smooth curve. It should look the exact same. The size shouldn't change. The shape shouldn't change. It's just a translation. We just picked it up and we shifted it right 4, up 2. Okay. So again, the whole point of going to vertex form is so you can see those 2 shifts. All right, so we're going to get on to solving now. So I'm going to write that as the directions down here. Solve for x. All right, so the first thing I want to take note of is the highest degree. This is telling me how many solutions I should anticipate. So I should be thinking I'm getting 2 solutions. They could be real or imaginary, but I definitely want to get 2 of them. And we're going to solve, today's our goal is to complete the square. We're assuming these can't factor. That's why we're using a different method. So again, we'll just read through the directions. Isolate the variable terms. So get the variables alone. So I'm just going to move over the 7. X squared minus 6x equals -7. Okay. Most important part of completing the square, make sure the leading coefficient is a 1. If not, you divide it out. Clearly it's a 1. This is a 1x squared, so we're in good shape there. Step 2 says take half the b term, square it, add it to both sides. Who's our b term in this case? -6. Good. So I'm going to take -6. I'm just going to write it out, and I want you to do the same thing. It's going to be important to see what we're writing out. Divide it by 2 or cut it in half. -6 cut in half is -3. Wrap it up, square it. I should get a +9. Okay, so I'm taking the b term, cutting it in half, squaring it. Now we add that to both sides. So x squared minus 6x plus 9 is -7 plus 9. Then we're going to factor the variable side. And again, it should always be the exact same 2 terms. Multiplies to 9 but adds to a -6 should be x minus 3 and x minus 3. -7 plus 9 should be a +2. Okay, I can rewrite that now as x minus 3 squared equals 2. Now, if the question said write it in vertex form, I would just move over the 2 and describe the shift. Okay, but if it wants me to solve, which is what this is saying, I have to solve for x. What would I do to get to this x? I would want to get rid of the what? The squared, so I want to take the square root. Now, don't forget, we talked last week, there's a plus and minus when you take that square root of any even root. The square root is an even root. So I'm going to get x minus 3 equals plus or minus root 2. And then lastly, I just want to add over the 3, and I'm going to make that in front of the plus minus, so I get x equals 3 plus or minus root 2. Okay, so my 2 answers are x equals 3 plus root 2 and x equals 3 minus root 2. are the two solutions to this equation, which tells me this wasn't going to factor nicely. I didn't get two nice answers. I got two hideous answers. So it was impossible to factor, which means I had to use a different method. And one of those methods is completing the square. We'll do another one tomorrow. Okay. So the method behind it doesn't change whatsoever. It's the same thing over and over. They can just get uglier. Obviously, they can put fractions in there. They can make an a value greater than 1. And we'll just kind of tackle each one differently. So let's try the next one here. Okay, so I want to keep the variables on one side, move the constant to the other. X squared plus 4/5 x equals a positive 1. Okay, most important check is the a value 1. Yes, so that makes life semi-easy. So I want you to do the same thing on paper. You're going to take the b value, 4/5, cut it in half, which means divide by 2. Now again, I would just type that in your calculator. So take your 4/5, divide it by 2. You want a fractional answer, no decimals in any of this. What do we get for 4/5 divided by 2? 2/5. Then we have to wrap that up and square it. Okay, and again, you can use your calculator, but you should be able to square in your head. Just square the top and bottom. I'm getting 4/25. Okay, so 4/25 is the magic number we're adding to both sides. So x squared plus 4/5 x plus 4/25 equals 1 plus 4/25. Okay, now, I'm guessing the left side looks a little intimidating to factor. But this is what I want you to take note of here. So look back at this. You don't have to write anything down. Just look up here. I'm going to go back to this example. When I factored this, notice I had x minus 3 and x minus 3. Now I want you to take note of the number I squared. Who did I square? Minus 3. And those were both minus 3. Go back to this example. And again, just look at mine. I had x minus 4 and x minus 4. And the number I squared was -4. It's not coincidence. It's going to happen every single time. It's part of completing the square. So if this looks intimidating, you just have to say, who did you square? 2/5. So this should be x plus 2/5 and x plus 2/5. If you don't trust it, do the math. 2/5 plus 2/5 adds to 4/5. 2 times 2 is 4. 5 times 5 is 25. It should work out every time. It's always the number you squared. This, if you can't add in your head, add in your calculator. 1 plus 4/25 should be 29/25. Then I'm going to write this as the quantity squared. X plus 2/5 squared equals 29/25. Okay. Now, same idea. I want to take the what of both sides. Square root. Now, here's where we've got to be careful. All right, on this side, I'm left with x plus 2/5. I want you to think about this side before you write it down. Do you happen to know the square root of both of these, one of these, none of these? One of them. Which one? 25. So we can just do that. The bottom is just going to become a 5. We know that answer. Do we know the square root of 29? So we're going to leave it the square root of 29. But the 5 is coming out because we know that answer. If we don't know it, it stays in. If we know it, it comes out. And then lastly, I'm just going to subtract over the 2/5. So I have -2/5 plus or minus root 29 over 5. Okay, so again, if I know the square root, it comes out. If I don't know it, leave it in there and bring that term over. And again, you have two answers. You have -2/5 plus that answer and -2/5 minus that answer. Okay, they're always going to come in conjugate pairs, remember. Always in conjugate pairs. All right, let's look at example 3. Now, they're just trying to mess with you a little bit. Clearly, these are not in the right order, right? So I'm just going to reorganize them. That x squared term has to come first with a -x squared, then the minus x, then the plus 1. Okay, so I'm going to start with the most important part, the a value. What does the a value have to be? Has to be positive 1. Is this a positive 1? No. So I have to divide everybody by a -1. And everybody means everybody. Don't leave any term out. Every term gets divided by a -1. So this should become a positive x squared a positive x, a negative 1, and 0 divided by who cares is still 0. Okay, the a value has to be a 1 for completing the square to work. Okay, so again, I'm going to take the b value. What's our b value? What's our number? One. Cut it in half. That's easy enough. I get 1/2. Then I have to wrap it up and square it. So I should get 1/4. 1 squared is 1, 2 squared is 4. I also have to move over the 1. I have to get the variable by itself. So I should have x squared plus x plus 1/4 equals 1 plus 1/4. Okay, so I kind of did 2 steps at the same time. I took my b value, I cut it in half, I squared it, and I'm moving that constant over. Now again, this should factor real nicely. It's always the term you squared. So I should have x plus 1/2 and x plus 1/2. And 1 plus 1/4 should be 5/4. Again, if you don't trust it, a half plus a half is a whole. That makes sense. And 1 times 1 is 1, 2 times 2 is 4. It works out. So I should have x plus 1/2 squared equals 5/4. I'm going to take the square root of both sides. So that's x plus 1/2 equals plus or minus. Okay, again, just a little self-talk. I have 5 and 4. I know the square root of 4 is a 2, so that comes out. I don't know the square root of 5. That's going to stay in. And then lastly, I would just subtract over the negative, the 1/2. So negative 1/2 plus or minus root 5 over 2. All right, I'll give you, well, I guess we'll talk through another one, and then we'll try some on our own here. Any questions on that one? All right, let's look at 4. What's our first problem on number 4? The 3. I can't have a 3, so I have to divide everybody by 3. Okay, completing the square only works if that a value is a 1. So that's x squared. 24/3 is really 8. Minus 5/3 equals 0. Okay. Then again, I want to get the variables by itself, so I'm just going to move over the 5/3. Okay, I'll give you a minute to complete the square. Take that b term, cut it in half. Square it, add it to both sides. Does 16 sound like the number we're adding to both sides? So again, I'm taking negative 8, dividing by 2, I get negative 4. Square that, I get 16. So I'm adding 16 to both sides. This should factor real nice. You actually even know the factor. It's the number I squared. So this should be x minus 4 times x minus 4, or x minus 4 squared. 5/3 plus 16, is that 53/3? Oops, does that sound right? Okay. Again, just going to take the square root of both sides. So x minus 4 equals plus or minus. I don't know the square root of 53, nor do I know the square root of 3. So I'm going to leave them both under the root. Okay, I don't know either one. So I've got the square root of 53/3, and then all I'm going to do is add over the 4. So I'm getting 4 plus or minus the square root of 53/3. Okay, because I don't know them, I'm not going to simplify. Neither of them break down. It is what it is. All right, looking at 8, or sorry, number 5. What is your gut hopefully telling you to do on the right side? Distribute, clean that up, FOIL that out. We have to set this equation equal to 0 before we can complete the square. So clean up the right side here. And again, we got to set it equal to 0. Check my math. I'm getting x squared minus 14x plus 13. Anyone agree with that? Yeah? Okay, good. All right. Now again, I'm going to complete the square. This is an easy one because the a value is 1. So again, move your constant over. I'll give you a minute to play with it. Move your constant over. Take your b terms, get your variable on one side. B terms, cut it in half, square it, add it to both sides. Was 49 the number we added? Let's see, so I'm getting this to be x minus 7 and x minus 7. And on this side, that gets me a 36. So I can say x minus 7 squared equals 36. Again, I'm just going to take the square root of both sides. Don't forget the plus minus. That 2 is telling me there's 2 answers. So I've got x minus 7 equals plus or minus. The square root of 36 is nice. It just turns out to be 6. So now this is turning out to be nice numbers, which means it should have been factorable to begin with. This is not one that was unfactorable. I'm going to write both of them out. So I should get x equals, I'm going to add that 7 over, 7 plus 6, and x equals 7 minus 6. Right, I'm just going to, I jumped the gun there. I just added the 7 in my head. 7 plus 6 and 7 minus 6. So I get x equals 13 and x equals 1 for the two solutions. And again, because they came out nice, that just tells me this was factorable from the get-go. Typically, what you'll see in the directions are going to be like simplest radical form, simplest a plus bi. That's what's going to lead you to do something besides factoring. Okay. All right, one last one. Again, they're just trying to mess with the order a little bit. Remember, variables on one side, constant on the other. So again, I'm just going to subtract that 3x over and leave the negative 2. Okay, this one's an annoying one because that a value has to be a 1, so I have to divide everybody by 5. The a value has to be a 1 for completing the square to work. Okay, and we don't care about ugly fractions. We can use our calculator, so don't let those scare you. So again, I got to take that b value, cut it in half. I'm just using my calculator to do that. I got negative 3/10. Then you have to square that. It should always be a positive number. 3 squared is 9, 10 squared is 100. So I'm getting 9/10 to both sides, or 9/100ths to both sides. So that's x squared minus 3/5 x plus 9/100ths. Equals negative 2/5 plus 9/100ths. This side will factor. Again, if this freaks you out, it's always the number you squared. That's why we write this out so you can physically see the number you squared. It should be x minus 3/10 and x minus 3/10. Again, if you check the multiplying, negative 3 times negative 3 is 9, 10 times 10 is 100. Those also add to negative 3/5. This other side, I'm just going to type in my calculator. Negative 2/5 plus 9/100. I'm getting, does negative 31 over 100 sound right? Okay, now this one's going to have something else in it, so hopefully you caught it. I'm going to take that square root. So I'm going to get x minus 3/10 equals plus or minus the square root of negative 31 over 100. I'm going to add that 3/10 over, so I'm going to get 3/10 plus or minus. Now let's be careful here. The first thing I notice under the radical is a negative. What does that tell me my answer has in it? An I. This is definitely an I answer. Anytime we have a negative under a radical, so there's a reason we did the imaginary numbers first. Do I know one of these square roots? The bottom becomes a 10. I don't know the square root of 31, so that's going to stay. But you have to pull the I out if there's a negative under the radical. Okay, so that shouldn't surprise anybody. We spent not a lot, but we spent a couple days with imaginary numbers. Anytime there's a negative under there, we got to have that I out in front. Okay. All right, so we've got plenty of time to practice. I'm hoping you can get through all of this before we leave here. Turn to the practice page. We're going to go 11, 17. Let's do 21, 29 on the front. So 4 on the front, 11, 17, 21, 29. On the back side, let's go 35, 43, and 53. 35, 43, 53. So I think that's just 7 problems. Okay. Hopefully the answers match up. If you strongly disagree with one, say so. Obviously typing these in is super annoying, and I certainly could have made a mistake. So if you strongly disagree, just let me know.